Lesson 3, changes in matter. So we're going to talk about the two categories of how matter can change. Physical change and chemical change. So a physical change is a change that alters a substance without changing its composition, without changing what it is made of. So for example, you could cut paper and you've changed its shape, but it's still paper. It's just smaller pieces of paper, right? It's still the same composition. Another example is you could break a crystal, right? Like salt is a crystal. You could have a huge hunk of salt and you could smash it and break it into smaller crystals, or a big quartz crystal and break it down. But those smaller pieces would still be the same composition as the original larger piece. A phase change is another type of physical change. So that's when you have a transition of matter from one state to another. So for example, you could boil a substance and change it from liquid to gas. You could freeze it and change it from liquid to solid. You could melt, you could condense. Phase changes are physical changes because they do not change a substance's composition. Oops. And so for example, ice. Here we have a photo or a diagram of ice and of liquid water. And if we zoom in, you can see that we have not changed the composition. If we take if we look at a water molecule, we have the red represents an oxygen atom, and then those two blue Mickey Mouse ears represent hydrogen atoms. I'm going to put a little H there. And in ice, the water molecules have a regular pattern where they're bound to each other with hydrogen bonds. These little dotted lines are hydrogen bonds. We'll learn more about those in subsequent lessons. And then in liquid water, if you heat it up enough, the water molecules will have enough energy to break those hydrogen bonds. They'll start moving fast enough to break the bonds, and then they slide past each other and they form little temporary hydrogen bonds that form and break continuously in liquid water. But if we were to zoom in, we'd still see the water molecule is the same composition. It's all still water molecules. So those are phase changes. And now a chemical change is a change that involves one or more substances turning into new substances. Here's an example: combustion of methane gas. So if you have a gas stove or a gas fireplace or a gas fire pit, that runs on methane gas. It's often called natural gas. And the chemical formula for methane is CH4. And we can see here that there is one carbon, so that middle molecule is carbon. And then coming off of the carbon are 4 hydrogens. I'm going to draw them, their bonds kind of like sticks here. 3, and then this one kind of goes back. It's a 3D molecule, 4 hydrogens. So in order for methane to burn, it needs to have oxygen, which of course it gets from the air. And then we need to put in some energy. We need to light it, like we need a lighter, right? Or our stoves often have lighters in the burners. Once that energy is added, then these bonds break. So we'd have a breaking of the bonds between carbon and hydrogen. And then the bonds between these oxygen molecules, here's an oxygen molecule, it's actually a double bond. You have 2 oxygen molecules. Those will break as well, break apart. And then there'll be a rearranging and we'll have some new molecules. We'll have carbon now that carbon is going to bond to 2 oxygens and get carbon dioxide. Some of the oxygens are going to bond with hydrogens to get water. So we have new substances. So in a chemical change, the bonds between atoms break and new bonds form. The other word we have for this is it's a chemical reaction. So chemical changes are always chemical reactions. And so this up here is a great example of a chemical reaction. So when we are observing, when we mix 2 things together and we want to know if a chemical change has happened, We do not have powerful enough microscopes to be able to see the actual atoms and if they're formed with, have new bonds with other atoms. So we have to look for visible signs that we can see without a microscope. And so here is a list of signs that a chemical reaction has occurred. And chemical reactions, of course, always form new substances. So how do we know that new substances have formed? Well, there's 6 telltale signs. You might see a color change. So you might mix 2 liquids and then a new substance forms that's a totally different color, and you'd see a color change. You might have an odor change, a smell, a new smell. So that would indicate that there would be a new substance. You might have a temperature change. You might have, so temperature change, it might get hot. The reactants might be cooler than the products, might get cold. So like an ice pack, that's a chemical reaction, one of those little those chemical ice packs. You might have gas production. So if it was liquids, you would see bubbles. You might see a light formation. We'll look at an example in a moment. Or you might see an appearance of a solid. Sometimes you mix 2 liquids, and the new substance that forms is actually in a solid state. So you would see a formation of a solid that would then drift to the bottom of whatever container you put it in. So you'd see some little solid bits here in your liquid that would float to the bottom. So this particular chemical change up here, we would see a temperature change, right? It would get hot. That's why we do it. It works our stoves. So temperature change when methane combines with oxygen in combustion, we have a temperature change. Whoops, I said charge change. We would also see light production, right? When you light your gas stove, you can see it, the flame. Light formation. Okay, in the next half of the video, part 2, we're going to look at some examples.